Problem 11, section 1.8. Sketch the graph of the function to determine the type of discontinuity. Well, you could sketch it, but it is not necessary in this case to sketch. You can address this algebraically. What type of discontinuity does f have at x equals negative 3? So negative 3 appears here. So you want to know the left hand limit using that function and the right hand limit using this function. So x approaching negative 3 from the left means x is less than negative 3. So the function, the rule in question is x squared plus 2. Plug in negative 3 to get 11. Whereas from the right, what happens is I'm going to use this rule because I'm to the right of negative 3. Negative 3 times negative 5 plus 2. So that's a 17. So 11 to 17. This is a change of height. So this is called jump discontinuity. What happens at 0? So 0 is addressed over here. So the left hand limit at 0, I'm going to use the rule negative 5 plus 2. You get a 2. To the right of 0, you're going to use this rule. Plugging in 0, you get 0. So what happens at 0? Well, we are going to jump again. What about at 3? 3 gets split over here. To the left of 3, notice this is denominator. So this goes to one of the infinities. On the right, I get a 1/4. So this goes to an infinity. All right. So this is actually going to go to negative infinity because of that. Because of that negative. All right. So this is going to be an infinite discontinuity. All right. Next problem. Which of the following functions are continuous on the entire real line? 1 over x, it is not continuous when x is 0. Square root x, it is not defined for x less than or equal to 0. You see, 1 over x is also not defined for x 0. Square root x is not defined for x less than 0. Sin x, now that is continuous and defined everywhere. So it is C. Next question. Is the following function continuous everywhere? Well, sine is continuous, cosine is continuous. The only difference is at pi over 4. So we need the limit from the left and from the right and to agree with the value. So this was problem number 13. Find the value. So since pi over 4 is a cut point for this piecewise defined function, f at pi over 4. X equals pi over 4 appears here. So the rule is cosine x. So f of pi over 4 is cosine pi over 4, that is square root 2 over 2. Now, find the limit x approaching pi over 4 from the left hand side. So when you approach pi over 4 from the left hand side, you're looking at the rule sin x. So you apply pi over 4 for here and you get root 2 over 2. Likewise, coming from the right, you're going to use this rule that gets you again root 2 over 2. So value is equal to the limit. So this is continuous. Okay. Its sine is continuous throughout, cosine is continuous throughout. So we have to worry about the piecewise defined feature only at the cut point, and it is continuous. So we are fine. Where is f continuous? Use interval notation. Look at this. This is defined for 4 and higher. So closed interval 4 to infinity. Infinity is always an open interval. All right. If you want to see the picture graph of this, it looks like this. Right. So 4 onwards. Next, find the value of the constant c that makes the following function continuous. Cy plus 3, cy squared minus 3. Well, this is a polynomial, this is a polynomial, so they are continuous. The only part is the break point at 3. So you want to use left hand limit and right hand limit. When so our independent variable is y. When y approaches 3 from the left, you are going to use the first rule, apply 3 for y. So you get 3c plus 3. But when you are approaching 3 from the right, you are going to use this rule. So c y squared, c 3 squared minus 3. So it's a 9c minus 3. Well, if you want this function to be continuous, then left limit has to agree with the right limit. That's a minimum. So 9c minus 3 has to be same as equal to 3c plus 3. Get the 3c to the other side, get the negative 3 to the other side. So you get 9c minus 3c and 3 plus 3. 6c is 6, so c has to be 1. All right. Next questions, I'll start on the next video. Until then.